Now we are transitioning to our panel discussion on sustainable silicon. We are honored to have 3 distinguished experts for this panel. First, we have Nana Singh, and I'm going to give a short bios. I could spend a lot of time explaining all of their accomplishments, but I'll just take a couple of things for each person. First, we have Nana Singh, who is the Chief Procurement Officer and VP of External Manufacturing at onsemi, a leading semiconductor company focused on intelligent power and sensing solutions, targeting the automotive and industrial markets. Nana and her team are managing more than $5 billion in annual spending to ensure having all the necessary materials at the right quantity, right quality, and the right cost. In addition, they juggle with supply chain risks and support the implementation of onsemi's sustainability roadmap. Next up, we have Srabanti Chowdhury, who is an associate professor of electrical engineering and a senior fellow at the Precourt Institute of Energy at Stanford. This year, she received the Technical Excellence Award by the Semiconductor Research Corporation and became an IEEE Fellow for her contribution to wide band gap semiconductor technology. And last but certainly not least, we have Sadasivan Shankar. Sadas is the Research Technology Manager for Microelectronics at SLAC National Laboratory. He is also an adjunct professor in Stanford Materials Science and Engineering and a lecturer in the Stanford Graduate School of Business. He spent about 2 decades in the semiconductor industry and a few years at Harvard as both the first distinguished scientist in residence and as the first Margaret and Will Hurst lecturer before joining Stanford. Thank you all for being here. Really appreciate it. So we have a lot to cover in a short amount of time, so we'll try to get right to it. The first question I have for Nana is, what does being green what does being green mean to companies in the semiconductor industry today?
Well, being green cannot just be a slogan that you put on your website or posters that you put around the cafeteria. So is this really rooted in our core value of driving breakthrough technology that delivers on sustainable, better future? So what this means is that really in our culture mindset, right, in all aspects of what we do in terms of product, operation, and our branding. So for example, we would really have to internalize and measure ourselves starting from our product market strategy. So who we actually serve in the end market, are they sharing the same vision, right? And our product, do they have the proper product carbon footprint, right? In the manufacturing infrastructure and operations, in the selection of our bill of materials in our supply chain, and of course, ultimately converging our environmental together with our social and governance responsibilities. So that's what it means to us.
Wonderful. Thanks so much. Anything that either of you would like to add?
First let me wear the industrial hat because your question was directed industrially. For green to gain traction at the company level, 2 things need to happen. One is there should be an impending regulation, or consumers should be willing to pay for it. Because as I keep saying, corporations are for profit, and they say it publicly. So for it to hit companies, either all of us, when we buy goods, we are willing to pay that extra for the green, or there is some part of the government which is essentially going to push in regulation. Then the companies will pay attention.
Great. And anything that you'd like to add to that?
I think you can hear me, right? Yeah. I resonate with 2. I think it starts with the awareness again, and using my professorial hat, I think we have to make people aware starting from kindergarten. Like that's internalization, I would say. And we are doing certain things that we see that the burden of this problem is more towards the younger generation than us. So how do we prepare them to think green and act green is probably the way I would resonate with the other two comments.
Great. Thank you so much for that. I have to say, this is very exciting for me. I'm getting back to my roots because before I was an economist, I was an electrical engineer. So this is bringing me back. I have two electrical engineering degrees, so it's really exciting to be up here with technologists like the three of you. Okay, so let's talk a little bit now about some technical challenges. And I'll come first, Srabanti, to you here. Why does the semiconductor industry have such a big climate impact, and what technical challenges are companies experiencing now?
Yeah, I would, in the interest of time, I'll just kind of highlight a couple of very nuanced issues. So first of all, the growing demand of products that are powered by semiconductor, we cannot deny that. We are all hungry for more and more speed, more accuracy, everything, right? So that is inherently tied that you need semiconductors which can serve those purposes. And unfortunately, we are at a time that the processes and technology of semiconductor has matured to the max. And any new efficiency or any new functionality that we demand constantly needs the semiconductor processing to become even more complex. So this is the challenge of our time. It wasn't there even 10, 20 years before, which is why we didn't discuss this topic as vigorously as we do today. So that's the challenge, and that is why it impacts the climate crisis, because some of the products that come out of the materials processing, the gas emission, even though the product is so-called green, but the process is not green, we know that. So that's one. And the other thing is the challenge is actually, as I said, it's very nuanced, because semiconductor is part of the solution. It takes you towards the greener technology, but is it also part of the problem? This decoupling is very important, and sometimes it is extremely heavy on the transparency, like how much we are willing to share all these proprietary processes and things like that. So that makes it so big of a challenge for the industry. There are several others, but I would just highlight on this one at this point.
Yeah, and thank you for that. And how about you, Sadas? Would you like to add something to that?
Yeah. From the industrial perspective on the semiconductor technology, I see actually four different issues. The first is input, that is the energy for manufacturing is increasingly becoming very high. It is expected by 2030 that the energy spent on manufacturing a chip, which is about 50 grams, is going to exceed that of the whole nation of Australia by 2030. So the energy for manufacturing is very high. That is the problem. Then the energy of computing on the manufactured chip. If the top 500 supercomputers were to all have the same computing power as the biggest machine in the world today, Aurora or so, they will exceed the power, the total electricity used by Australia. So as a usage and manufacturing. And then comes all the other issues, material usage, water usage, recycling materials. So there are a whole host of issues because of the speed of this industry. It can be a leader if it chooses to.
Wonderful. Thanks so much for that.
May I just add one quick comment on that? So I know some numbers help here. So today the problem is not as intense as it can be. So it's the GHG is only 0.3% that is produced by the semiconductors. It's tiny, but it can go to 4% if we don't do annually, if we don't do anything. So I think that's an important thing to remember. But this 4% can control the rest 70% of the GHG emission that we see today. So that is why it makes it so difficult. How do we make this 1% or 4% GHG through semiconductor industry important to control the rest? That makes it so important.
Right. Well, thanks so much, for that. This is really a great topic to be talking about here at Stanford today, partly because we're obviously in Silicon Valley, but as you know, sustainability, as you know, Srabanti, sustainability is such a big issue right now at Stanford with launching our first new school in several decades, our School of Sustainability. So it's really exciting to be talking about this. So next I'd like to get to a little bit supply chain, or Nana, is there anything you would like to add to that?
Yeah, actually I wanted to, I think it's it's actually wonderful that we have this research about all this impact. But as a practitioner and execution of this, one of my biggest challenges is the reporting. First just try to understand our baseline as a company, right? Well, exactly to Sadas and Shravanti's point that, there's a lot of complexity in the input, and how do we measure first our baseline, try to understand where we are, and throughout the supply chain, working with our suppliers and ecosystem partners, and then trying to set the target, of course, right? And then how do you measure and validate the what you have put in place, whether they the metrics are moving towards, and the metrics that's moving towards the goal. So that is actually a big overhead to our company too, is to try to manage all of that. So I'm sure we'll talk a little bit more about the cost of sustainability, but that's pretty much part of that too. Yeah.
Right. Okay. Wonderful. Thank you for that. So next, perhaps we can touch on some supply chain issues and geopolitical challenges. And maybe, Nana, I'll start with you on this one. Could you talk a little bit about the challenges within the semiconductor supply chain, for example, supply chain disruption, and of course, geopolitical risks and uncertainties now and going forward?
It's actually a very big topic. I think, especially in the last couple of years, everybody suddenly had this great awareness of the supply chain challenge. But the truth is, actually, semiconductor industry is used to demand and supply imbalances. That's the nature of our industry. Actually, it's typically very cyclical. But I think what has really made this recent disruption particularly severe is a couple of things, right? I think first, the unexpectedness, the COVID hit, right? The uncertainty surrounding when this will end, the disruption to the flow of information, communication, goods, and materials, which is primarily caused by all the geopolitical tension and war that happened also during this time, really made this whole thing a lot more severe than expected. I think, but then out of this 2 years, we really developed a new norm, I would say, even in our industry, in terms of our business model and how we operate. So hopefully we're learning from it.
Wonderful. Sadas, would you like to add something to that?
Yeah, so on the supply chain, I think we didn't realize the issues of supply chain, more obviously till this COVID came, and we suddenly saw that there were not enough masks and all that. The semiconductor technology is like that. If you talk to the right people in the government, in the US government, they will tell you that they are very much worried that a lot of the hardware that is being used is manufactured overseas with no control over the design and the hardware aspects of it. So I would kind of paraphrase Andy Grove, who was the CEO of Intel where I worked. He said that the security thing for batteries, he was trying to make an argument that US should get into the manufacturing. If you look into the US economy, US spends only 12% of the GDP goes into manufacturing. Mostly it's heavily service-centric. What we fail to realize is that the 80% or 75% service economy is all based on manufacturing. It's based on some material goods. And in an information-driven century such as this, everything is based on computing, from AI to that. So although manufacturing looks like not very attractive in terms of the return on investment, manufacturing gives you some sort of an insurance against a potential black swan or a downside. So I think the supply chain, the best way of trying to avoid that is to be very local. But the problem is if you're very local, you're not leveraging the expertise elsewhere and the availability of materials elsewhere. So that trade-off needs to happen. In US, I think we have shifted weight to service. China is about 28% manufacturing, or more than double the US, followed by India around 20%. You like numbers, Mark, so I'm throwing the numbers. So in terms of that, it essentially means that we have to shift. We have gone too far away from manufacturing, and we need to come back towards a more healthier combination of service to manufacturing.
Consistent with that, we had earlier this year at CEPR someone come speak from the Biden administration about the CHIPS Act, which had super complicated, a million different provisions, but at a high level, what it's striving to do is go in the direction that you described, reinvigorate the manufacturing sector for semiconductors specifically. I don't know, Srabanti, is there something that you would like to add to this?
I think, the problem is it takes time to come up with executable action items, right? That is, so how you start looking at a problem because of its complexity is probably only dealt by high-level researchers. And I think, as Siddharth and Nana has put it, I think if we can actually come up with executable action items, and I want to say one thing here, that semiconductor industry is very competitive in nature, but sustainability, hope it's not competitive, because if we put all those guardrails, around sharing information, and so that kind of inhibits it. So that is something, if we can work together to see how we can overcome those hurdles early on, and not when it is too late, that would be good.
Great. And Nana, I don't know, there's a lot been said since I don't know if it seemed like you might want to react to something that either Siddharth or Srabanti just said.
So I think I echo Srabanti's point about sustainability should not be competitive. The industry is very competitive, but this is one area where I actually do see a lot of healthy consortiums put together through, with our peers and our industry peers to really look at this issue and try to make this work. I want to make a comment with Siddharth's regionalization comment. I think that's definitely one of the new norm that I'm seeing as we come out of this COVID and now we're actually going through a downturn in the industry. But this regionalization is one thing, but what consumers may not know is actually implicit in that is a redundancy, which means cost. So don't forget, I'm a chief procurement officer, so cost is always in my head. So I'm sorry if I keep bringing this up, but it is something that we monitor very closely, and how we continue to provide competitive cost to the market while we manage all of these regionalization activities or national policies, right? In addition, I think the other major change that we have observed with this disruption is the business model. There's actually a major paradigm shift because of this disruption and the chain of supply, the supply chain, the complexity of supply chain. A lot of people are trying to simplify their supply chain. So an example would be the OEM, the automotive companies. So before, they would typically go to tier one, like a Conti, a disti, right? We call them, and then they buy. The disti will buy through companies like onsemi, right? But now we see customers coming directly to us to work with us on the design, on their needs. So that actually really broke down the industry and simplify the flow, which hopefully will make this industry more resilient with the next disruption, which will definitely be another one. Yeah.
Okay, great. All right, well, thanks. Well, one issue that certainly we've alluded to a little bit in the discussion so far has to do with the trade-offs that are inherent with sustainability. So, Srabanti, I'm wondering if you can start us off with how we should think about the business case for organizations in the chip industry who have to weigh the cost and benefits of going green. It's one thing to say lofty, positive, wonderful things. It's another thing to actually do stuff. So can you talk a little bit about that?
Yes, and I would repeat my cliche of this being so nuanced, is that, these are very coupled equations, in lack of a better phrase. So how do you decouple the benefit and the cost is a critical parameter here. And so basically you have to think long term. The short term benefit may not be seemingly high. It may be, it takes that leap of faith. Like you want to either have a reputation that serves the first part of the equation. That means we're a green company, we're a green tech company, and reputation, always gets us started. Branding is important, things like that. So hope, and we are seeing this, the big companies, the big tech companies, they are taking that first step. Of course, if I may say, it's still convoluted. It's very complicated how they are going to actually be transparent, okay? But nonetheless, there is a first step. I mean, I want to, and on your question, so for example, I think it is so important for the tech companies to be able to kind of share their research, their learning, and also be able to, bring academic folks, because there would be several PhDs who can actually make the problem look probably more elegant than it is. So I think these are some of the first steps, but also the long-term and weighing this long-term benefit is critical of our time. And this is not happening as much as we would like to, So I think that is going to be the test of our time. I mean, I want to say that, there is a conference which happens every year in December. It's a completely very rigorous semiconductor people meet once a year in San Francisco called IDM, International Electron Device Conference. This is the first time, and I'm privileged to be a co-chair of this. We are actually hosting a sustainability-focused session in the conference. So that's definitely the first step. But again, I think the complexity is because people are not still, thinking about this on a day-to-day basis, and that's where we have to act on.
Okay. Nano, is there anything you would like to add to that?
I think the cost, I kind of accepted it as a given, as sustainability is going to cost money. I mean, you can't get it for free. Right. So
no free lunch.
No free lunch.
They taught me that in econ grad school.
Yeah. So it's a given, and so what we just have to work with it. I don't have a good answer to solve that cost formula, but you just take it as a given and continue to launch competitive products, despite the increasing cost environment. The only thing I would call out for the government and policymakers is try to make our overhead as low as possible. I think the challenge has been a lot of the cost is not necessarily in the actual making the material that will make our environment greener, is actually in the red tapes that we have to pay to get through this. So that's one thing I would like to point out. Yeah.
Okay, Srabanti, it looks like you, and then I want to let Sadas come in too.
Yeah, I mean, you bring up a great point. And, I will give a very specific example. If you go and look into manufacturing today, I think if we pose the problem of sustainability upfront, there are a lot of engineering that can be done that already saves the energy consumption by 50 to 75%. For example, I work on semiconductors, we do lithography. Lithography is a very critical step for every semiconductor process. But the cooling water that they use today is ultra-cooled. These are power-hungry chillers that cool the water down to 10 to 18 degrees C. I'm giving you absolute specifics. But some of this part, there is a laser process that takes you into this lithography. The success of lithography heavily depends on the laser. That doesn't need that much of cooling. And these are only being questioned today. So it is okay with a 32 degrees C capability. So if you just do the math in those, which is what graduate students are great at doing, they will find out that you will find out that this is right off the bat, you get 50 to 75% of energy savings just with that one lithography aisle, right? Lithography 2. So these are some of the things I think that should happen. We don't have to wrap everything with a lot of glittery things, but let the engineering start with sustainability in focus. And I think that can really answer a lot of hard questions.
Great. Okay, Sadat.
So I'm trying to see which topic to pick on, Mark. So maybe one way to talk about this is anything for, I think I will repeat myself and then kind of build upon that for companies to take, either the customers should demand it or there should be an impending regulation into their consumer market. Otherwise, companies are generally not interested. I mean, I can give you examples of my years that there is a vice president of sustainability, but he was never involved in any of the critical meetings that I was in. But he would present my slides.
Right.
Okay.
Right.
So that's the way companies think sustainability. It's a great window dressing. I'm not trying to paint all of them. It's great to say that we are doing it.
It's easy to say.
But
Talk is cheap.
yeah, exactly. But if consumers are willing not to pay for it, or if there is no regulation, there is no incentive, feel good is not good enough for corporations, especially the large ones, to make a difference. A simple example is ChatGPT. ChatGPT consumes huge amounts of electricity in training. Just for 55 days of training, it consumes electricity which exceeds per capita, and a human spends the entire lifetime of 75 years. It exceeds by 3 orders of magnitude just for training. Can you ask people not to use it? Unless there is an impending regulation or a cost. Same thing with crypto coin mining. I can kind of give examples. People tend to choose what is the easiest path. The most important thing are metrics. So I am part of an IEEE working group, which is essentially trying to develop metrics for sustainability, called Planet Positive. And the goal is to develop specific metrics that could be measured so that people can actually put themselves up. There's a Department of Energy project that I'm leading, which is essentially to put the energy of computing across different platforms, running different software algorithms. So our hope is by putting it out, at least some will be shamed, some will remain shameless. But the important thing is at least having the metrics is all we can do. Unless there is a consumers all rise up and say, enough is enough. Just unless you have a green stamp or something, we are not going to buy your product. I just don't see it happening. A simple example is, I was in Houston airport yesterday. They don't have recycling. I had this recycling, I was searching around and I thought I'll miss my flight. I just couldn't find a recycling thing. They have just one trash. Now, if you go to Switzerland,
Texas.
yeah, if you go to, and this is Houston airport, right? One of the most trafficked airports. Now, if you go to Switzerland, the trash can is this small. Everything else need to be put in elsewhere. So you see, there has to be a pull and a push. For companies to push, there needs to be something for them. Maybe a competitive thing. It is pre-competitive, but I can tell you my team was involved in lead elimination in Intel. Intel turned that into a competitive advantage. The only company to remove 100% lead. So my general thinking is companies still compete.
Right.
So we have to transfer it into economical model that works.
The Houston example that you just gave is interesting because a couple of years ago here at CEPR, we had a policy forum about California versus Texas, the different economic policy approaches, who's doing it better, because they're completely different. And anyway, but it was... And
in the plane I was giving the cup, they said, no, that cup is not part of the recycling, only plastic bottles we are asked to take. So, in fact, they forced me to throw compost into trash.
Right. Yeah, well, it's just, so I don't know, Srabhanti, or maybe Srabhanti, anything you would like to react? Saras said a lot of things there, so anything you would specifically like to react to there?
Yes, I mean, the thing is, I wish it was as simple as recycle in semiconductor, I think, and if we can simplify it, again, simplicity is always good, simplifying is always great. My personal struggle always, and I have actually, I took some of my grad students to this adventure during my class to solve some of the, or just show like the carbon footprint that you see whenever you book your flight ticket. How are those being calculated? How are these numbers making sense, right? And again, it's complicated. It's not easy. And semiconductor being a part of the solution, we don't want to chokehold it. That's very important because this can save the rest of the 96% of greenhouse gas emission, hopefully, someday. So applying metric is important. but at the same time, I think we have to be really calibrated in understanding sustainability and the role of semiconductors to it.
Great. Nana, anything that you would like to add?
Actually, you kind of just reminded me as I was thinking about our competition, right? Both of you talked about how this could be a race and it could be a differentiator. Yeah, but then on the other hand, as a semiconductor company, I compete with the Chinese semiconductor companies, Europeans, and every country, every company is based on where they're from. They may are subject to different requirements. So back to this, like sometimes I feel like, especially when it comes to the Asian countries, right? Their standards are a little bit different. You feel you're a bit. It's not a level playing field, right? And that they have a bit more advantage. So yeah. So I was just kind of thought about that, and indeed, that is something that we should address.
You should look at the size of the trash can, right? So that gives you an idea of how important sustainability is.
That could be one measure.
A simple measure, rule of
Good proxy.
Yeah.
So I have a couple more questions. One question I'd just like to ask, because we're in this policy realm, maybe Siddhas, you can kick it off. So it's at CEPR, one of the things that we try to do is think about how could policy be better. Mm-hmm. So let's just take the case of the U.S. It's a complicated world, dozens and dozens of countries. Let's just take the U.S. Is there any obvious low-hanging fruit for policymakers to do to move the needle in a positive direction?
I was actually involved for 7 years in the lead elimination, so I can use that as an example. The lead elimination effort came because lead was put in the first place, so we put in the lead. So that was an innovation in the 90s when we put in lead and brought in flip chip technology in. Then lead was in, and the only reason that there was interest to remove lead was a possible restriction from the European Union. That the 45 nanometer technology, European Union was pretty uptight about that they will only allow you to sell products which don't have lead in microfrost. Not that the policy was not in place. There was this impending dagger hanging over. So Intel said, we are the leader, so we are going to remove it anyway. So the low-hanging fruit is just the threat of regulation. You don't need to regulate, but say there could be. And companies are smart enough. They have scientists and engineers who will do the rest. After saying that, the estimated cost for removing lead, Intel has claimed, I don't know this because I was on the technology side, is about $100 million in 2007. That's a lot of money. Not too many companies can afford that. So to me, one way to do that, in my mind, is a circularity tax credit or something like that, a sustainability tax credit. People tend to respond to carrots as much as sticks. So something like that, a discussion on that, what would the economics enable, would be a great way to get to that.
Great. Okay. Shubhanti, anything you'd like to add?
I mean, I'm hopeful, and at the same time, I do think that sometimes regulations freak out people. Like sometimes when you put regulate, there is always a path or a plan B. I mean, we have seen some of that. And then, regulations somehow has its own sort of, boundaries. And if you can very carefully walk between those boundaries, then you're not regulating, even though you are using the concept of regulation. So maybe sustainability is I think the big companies or the ones who are capable of both, working with the carrot and the stick, to Siddhas's example, should step out. I mean, they put that kind of reputation, like you are buying, without naming names, but you're buying a company who is net zero, or this kind of branding helps, and then it helps other companies to inspire. So again, everything has to be calibrated. We don't want to take it into a situation where even though there is a veil that all these are being followed, but actually we are able to bypass all of that because we really don't have that amount of time. I think time is of the essence when it comes to sustainability and practices. I think that's what I would add to this.
Okay, great. Nona, how about you?
No, I don't have any.
Okay, okay.
Very well said. Yeah.
Great. So maybe each of you, but I'll start this out, this next question, Anna, for you. Do you have any predictions, hopes, or concerns about what the future might look like for sustainability in the semiconductor industry? Is it sort of we're on a certain trajectory and things might be 1% worse or 1% better? Like can you sort of try to give us a sense of the range of possible outcomes and what's going to drive whether we get to the good outcome or the horrible outcome or sort of middle of the road outcome?
I think we're going to get there. I think sustainability, we're going to get there. I think my hope or call to action were really for the need for the entire ecosystem, right, to move in the same direction, right, and to basically for the government and the regulators really to simplify as much as possible and standardize the regulation, the policy, and make it as transparent and as clear as possible. And finally, really for the market and the consumers to really recognize and reward businesses who are willing to commit and invest in sustainability. I think going back to the math, we take it as a given that there's going to be a cost, but it's for the longer term reward. What you said, right? Waiving the longer term reward, and it's for our future generations to come. So we just have to work through that. So I think it will be there. It just need a bit more. I think the government and regulators play a big role in this, in how to support the industry and the whole movement, and hopefully as consistently as possible. So there's less of so there's more parity. Yeah.
Right. Okay. Great. Surbhanti?
Okay, I'll start with concern and end with hope because we have to end with hope. So the concern for me, I feel, is there particularly two that worries me. One is the e-waste management, partly that Sadas alluded to, the size of the trash can. I think e-waste management is, again, the data is not very well available or not made available. The transparency of the e-waste management is important. But also, I think it is very critical to understand that, how does sustainability impact, or how does this process changes impact down the value chain, like both upstream and downstream, right? So those are some of the concerns, that how quickly and how well they will be, tabulated. There will be data available, and then the data has to also be broken into simple concepts, because people are not going to read pages and pages and pages of, data crunching, so to speak. So that translation has to start from industry, because they have the largest amount. They have the largest amount of data that is available. How do you manipulate that data? How do you condition that data and break it into simpler pieces so that others can absorb? So that's one of the concern I have. Hope they step up to that. Also, I think the global geopolitics, I should say, is a concern, because as I said in the very first question, that sustainability has to be a collaborative effort. And sometimes semiconductor is the new oil of the world. So people are super competitive about this. Geopolitics only makes it worse. That's my concern. And the hope is that, yes, we will get there. I completely resonate with Nana, because semiconductor will drive things greener. So the hopes are, it's going to happen. How quickly, and the sooner, the better we are,
Right.
So that's my hope. Again, I think I see a lot of undergrads, a lot of high schoolers who think about this. I didn't think as a high school student or an undergrad at all. So this makes me extremely hopeful of the generation that who are going to drive these changes much more than we could.
Wow. Okay, great. And maybe Sadas, you can, and then I'm going to open it up for a question or two from the audience. Sadas.
So I will kind of break the because we are talking about semiconductor industry into two aspects. One is input into the industry and what is output of the industry. Input into the industry is energy and materials. The energy it takes for manufacturing is on an unsustainable growth, as I articulated the numbers. The energy of computing is on an even more exponential growth. They cannot continue past 2030. There are numbers to back it up, Mark.
Okay.
But I'll just defer it for the time being. So the energy is a problem. Then the materials, input materials, there are critical materials that are needed. 17 of the lanthanides are considered critical, but there are also other critical materials like cobalt waste and things like that. That is an issue, and that's a security issue as well. So after the computers are done, only 10% or less are recycled from our smartphones and all that. The remaining is going to landfills in India and Philippines because those countries buy the waste from the Western countries. And this is true of landlocked countries in the UK much more than in the United States. But it's across the board. So now, these are the issues. There are solution pathways on each of them. The energy of computing, the energy of manufacturing, which is totally driven by extreme UV ray that is used in lithography, is now consuming about more than 80% of the electricity going into the fab, just to pattern. Now, do we need a 2 nanometer technology to get the performance of the computing at the end is a question, right? And that's a technical question, and that can be addressed. And my prediction is 10 years from now, computing will look very different from how it is today for various reasons, including climate change. In UK, the real estate development is cut off that you cannot buy homes close to data centers because they don't have enough electricity to spare. So this is not a faraway problem. This is a real problem. And all of that can be addressed by innovations in science and engineering. Being in Stanford, this is actually a problem that can be addressed. So I am hopeful on that, but it does need all of these pieces to come together.
Great. Okay. Thanks so much for that, and thanks to all three of you. So I'm going to open it up for perhaps a question from the audience right here in the front row.
Thanks a lot for a very nice discussion. I have a question for you, Sadas. You mentioned about the carrot and stick approach, which is, I believe, a short-term approach. It's whether you create incentives for the company to act coming from the consumer, or you ask the government to put regulations to meet the demand on a geopolitical level. These are short terms. As a part of a world-leading academic institute of Stanford, I would like to ask, do you believe that you can educate the upcoming generation of leaders to be more socially and morally responsible and aware about the impact of technology on lives? And how can they, was everybody able to hear? Or okay,
Yeah.
great. I was loud enough. So I was just wondering that if you can include some kind of program or curriculum to, you're talking about numbers, to educate the younger generation about these numbers. So when they become the leaders of Intel and Applied Materials and are talking about these control points in the supply chain, they are aware.
Sorry, I can answer that. Sorry, your name?
Yes, my name is Soumya Gupta. I'm actually working in quantum technology, so I'm part of the panel here.
Okay, fantastic. So the education part is an easier solution because the younger generation, my kids, as Sravandi mentioned, are much more aware of sustainability. They are willing to give up the money part in order to work on something good for the environment. So the education part is good. School, like the School of Sustainability here, can help catalyze that process. And Stanford is just one school, but other schools are getting into it. I was in Purdue. They want to have a big effort on sustainability too. So that is happening. Now, the carrot and stick approach is not that short term. And let me give you an example. There is an R&D tax credit in the United States. This is why companies have R&D here and manufacturing outside. I have argued in World Economic Forum and in articles that there should be a credit for translation. There could be a tax credit for sustainability. These can be long-term solutions. We have precedents on them.
Yeah, Thanks a lot for that answer. I still believe, like, although the younger generation is more aware and more informed about sustainability, they still lack the numbers or the ideas required for them to bring them into practice. They are willing, but they need the education.
Of course.
Yes.
Of course.
So I think universities
Of course.
shall think a bit deeper about it.
Of course.
Thank
We
you.
have a responsibility.
Yes, we are all responsible.
Subanti, have anything you'd like to add?
Yeah, thanks for that. Yeah, I think, as I was saying, that, I think this is driven by the younger generation, but they don't have the right tool set, which we do. So we're in that kind of a situation where we are learning together. We didn't face the problem as much they face, but we probably have the tools and they are more driven than us. I see this happening in my class. I mean, I welcome everybody to be a fly on the wall when I teach on energy and semiconductors and things like that. And I'm absolutely dead certain that our younger generations understand the problem way deeper than we are. So it's a little bit of responsibility on us. How do we provide them with the tool? And that's a constant education. And I really encourage, this is where industry, academia can collaborate, without proprietary issues or any of that, because this is pure and simple data crunching and making it into digestible bits and pieces so that they can use it, right? Yeah, that's
Emma,
what
anything that you would like to add to that? Okay, great. All right, I think we have time for one more question right here.
My name is Dirk Seinhava.
Let's get the microphone. Sorry. Just wait one sec.
My name is Dirk Seinhava. I work for a company, Sigasi, which is in the EDA industry, electronic design automation. So we make tools that make the chips. And as such, given yesterday's fire chat, I'm the janitor of the semiconductor industry. But we heard very interesting ideas about the sustainability, where we talked about awareness, collaboration, regulations, carrots and sticks. But most of those were addressing the beginning of life, the creation of semiconductor devices, and end of life, the recycling. We're not talking about the consumptions, the consumers. Well, we are talking about them, but is there anything that we can do? And I know this is heresy, since we're on an economic mission, to diminish the demand. I'm thinking, for instance, I was attending a presentation of a car. If you look at the ECUs that are used for cars these days, 20 years ago, we needed maybe one or two. Today, we have hundreds of ECUs in modern cars, so a tremendous consumption, and that's where the problem lays. Is there anything that we can do to regulate or provide carrots for the consumers to buy the right car, buy the right TV, buy the right consumer device?
So I can start off the answer, and feel free to join. On your comment on cars, there was a class, Professor Bergelman here, and I taught, we teach on translation. The electric vehicles are called computers on cars by people. So that's why the usage part of it during use is important, and EDA companies have a big role to play. Now, the point which you tried to make it is, which was in my closing thing, but I didn't get to, you can actually design for sustainability. In that way, your EDA tool, which are electronic, design tools for automated, can be used for sustainability as a factor. Now, in order for that to happen, there has to be some pull on the other direction, either from consumers or from governments or something else. And without that, that connection is good to discuss but hard to make. Because at the end of it, economists are going to ask us, did it increase the economy in a good way or bad way? And we just need to show them the numbers. So that would be my answer. I hope I addressed it, but I'm not sure. Okay.
Subanti, anything to add?
Yeah, this is a really tough question, and I wonder, if you look at California roads versus other places, I do. I mean, I count the number of, EV vehicles I see. This is, I think this connects to the cultural part also a lot. So I think sustainability has to be part of the culture. I mean, one great example is we used to watch movies where animals were used and there would be some harm done back in those days. And now every title, every movie ends with or starts with disclaimers that says no harm were done to the animals, right? So I think if we can do that with animals, we can do that with our planet as well. So, so I think, you know, I don't know if I can answer. I mean, I wish it was that simple, but it has to come in. It has to be part of the culture that this is actually making a stable environment for your kids. I think that resonates with us, or your grandkids, right? So if we can do that, I strongly believe that people are not, you know, averse to using an EV. They just need to know that why are we doing so. So the whys have to be constantly answered. And of course, you can give more horsepower. People will definitely go for it. So why not? Yeah.
Nana?
I think it's a very tough question to answer, but I get the point. It's very interesting. I was thinking, and I wonder if there's ever any measure data relating to if we all move to EV versus stay with combustion. Is what's the I don't know. I wonder if any of our
there's a lot of compelling data. The problem is a lot of the EVs manufacturing, if it's energy intensive, is manufactured from fossil fuel based sources.
That's right.
So the net thing is still need to be made positive in the green direction, not in the red direction.
Yeah.
So then the question is, do we as consumers, do we want to continue to advance, if you quote unquote, right, advance in our technology, which sounds like by your definition will create a lot of demand on the
That's right.
the environment.
Your point is actually a very subtle point. Economists call it the rebounds factor. So that if we become all green, everything will increase. We will use more computing, more materials.
Yeah, the Gibbons
That's
paradox.
not necessarily bad because the planet is getting 10,000 times more energy from the sun than we are using. So we can actually make it sustainable and still have a greener planet, provided we do it efficiently.
Great. Okay. Well, I think we should wrap up, and please join me in thanking these three panelists.